Hey guys, so we'll be using the same Java applet in this video, and we will find what happens when we change the stiffness of the spring, and we'll see how we'll change the stiffness of the spring and make it a little harder this time or softer, and we will see what happens to the extension when this happens. So let's look at it. This is our Java applet, and this here is the option to change the stiffness of the spring. It says soft, and here it says hard. Right now I was in the middle when we just calculated our stiffness to be 11.11 newtons per meter earlier in the previous videos. But now you can see, let's see, just hang the mass here, and I will be making it softer, and you will see that when the spring is softer, it extends more. You can see, because it's softer now, so it will extend more. However, if I make it harder, let's say this mass here, if I make it harder, there will be less extension, because now it will be difficult for this spring to extend even for this force. So let's see, let's keep it here, and we will find the stiffness of this spring at this point when it's here, and then we will see what happens to the value of K when we make it harder. So now we can see that we have a mass of 250 grams attached to the spring, which by now you should know that we always convert this into SI units, which becomes 0.25 kilograms. Let's find out the force associated with this mass. And the force of gravity associated with this mass is simply the weight, which is again mass times gravitational acceleration. So this becomes 0.25 times gravitational acceleration on Earth is 10. The force of gravity is 2.5 newtons. Now let's see when the extension. Originally, it was at the length of 30 centimeters. Alright, it had a length of 30 centimeters. Original length was 30 centimeters. The final length, let's see the final length when we attach this mass here. So let it come here on its stationary point, and the final length you can see becomes around, if I keep it here, move the scale here, you can see this comes here around 30. This is 40, so this is 39. So the final length is 39 centimeters. So the extension is simply the final length minus the original length. So 39 minus 30 gives me 9 centimeters, and I will have to convert this into meters as well. So this would become 0.09 meters, because from centimeters to meters you divide it by 100 simply. So now your force is 2.5 newtons, and for that force the extension is 0.09 meters. So in that case, first of all, you will find out the stiffness of the spring. We know our formula of Hooke's law, which is F is equals to K times extension. Now the force that was applied was 2.5 newtons, and the extension was 0.09 meters. So K would be, simply just divide both sides by 0.09. So this would just cancel here, and this would become 2.5 divided by 0.09. So if I use my calculator here, so I can see 2.5 divided by 0.09 gives me 27.78 newtons per meter. This is the new stiffness of the spring. So what happens? Earlier, the stiffness was the stiffness previously was 11.11 newtons per meter. But when I hardened the spring, the new stiffness becomes 27.78. So you can see an increase in value of K signifies that the spring is harder now. It is difficult to pull it downwards because there would be more force required to move it, to extend it to some distance. So this is our new extension, 27.78. Now remember, always remember, to find whenever you are dealing with a spring, always use a known force, a known mass, and find its extension using the ruler, and firstly find out its K, the stiffness of that spring. Once you have the stiffness, now you can do anything with that spring. Now let's see. We know the spring, remember the stiffness of the spring, which is 27.78 newtons per meter. If I'm correct, 27.78. Yes, I'm just rounding it off. So this is our new stiffness. Now let's see. Let me just take it down. Okay, all right. Let's just take it down. Let's now attach a mass. This mass here. I am attaching a mass of 100 grams now. Let's see what is the extension. So the mass is 100 grams. These steps should be easy now. Convert this to kilograms. So 100 divided by 1000 to convert it to kilograms. This would give me 0.1 kilograms. Now find out the force associated with it. Force of gravity, which is equals to weight, which is mass, times gravitational acceleration. So this is 0.1 times 10. The weight is 1 Newton. Alright? So we know the stiffness and we know the weight now. So simply we have to find out the extension that it will have on this spring with a stiffness of 27.78. So our rule is F is equals to K times E. We have to find the extension, so our rule becomes F is equals to F divided by K is equals to E. The force is 1 newtons divided by the stiffness of the spring, which is 27.78. This is our extension. So let's find out the extension and we will see whether physics is working. So here it is. So 1 divided by 27.78. So this gives me 0.035 and what is the full answer? 359. So let's 3599. So let's take it as 0.36. Just round it off. 0.36. Remember, the answer will always be in meters because those are the units that you have used. Newtons for this and newtons per meter for K. So your answer will be in meters. Now let's just convert this into centimeters because our scale here is in centimeters, so it would be easier for us. So our extension would be, multiply this by 100. I think this is 0.036. Yes, this is 0.036. So multiply by 100, it would give me 3.6 centimeters. So my original length is 30 centimeters and my extension is 3.6 centimeters. Let's see if we are correct. The final length should be 33.6. Let's see. So this is 30, this is 31, this is 32, this is 33, and it's somewhere in between 33 and 34. So we can assume it's 33.5 or 33.6. So you can see that physics is actually working, guys. Now this was one example. Using the same stiffness constant, or let's say, yeah, using the same stiffness constant, let's find the mass of an unknown substance. Let's attach it here. So our stiffness constant changed to 27.78 newtons per meter. Let's find out our extension. Our original length was 30. Now our final length is 41. So original length was 30 centimeters and final length is 41 centimeters. So our extension becomes 41 minus 30, 11 centimeters. Let's convert this into meters. So this would be 0.11 meters. Divide this by 100. Now using our formula, F is equals to K times extension, where this is the K, let's find out the force of gravity. So force of gravity would be given by 27.78 times 0.11 meters. So using our calculator here, 27.78 times 0.11. This gives me force of 3.0558. Let's take it as 3.056 newtons. Now this is my force. But I want to find out the mass that I attached. So very simple. Force is equals to mass times gravity. So the mass in kilograms would be given by force divided by gravity. So 3.056 divided by 10 give me the mass, which would be equal to 0.3056 kilograms. Now this is my mass in kilograms, and if I want to make some sense here, if I want to convert this into grams, just multiply this by 100, by 1000, sorry. So let me just change the color, it's getting monotonous here. So 0.3056 times 100 gives me my mass in grams, which is 305.6 grams. So let's see if it makes sense. You can see that it's a bigger mass than 250. So yes, it makes sense because it can be 305.6 grams. So you see that physics is working. Obviously I can't find this mass here, but you can see that physics is working. Even when we change the softness and we, you know, we can find any. You can try this at home, and you can keep changing this one, and you can find the stiffness of the spring by putting a mass here and noting the extension and simply dividing the force by extension, and you will get the stiffness of the spring at every point. So that is how you play with stiffness and the spring systems. So I hope you understood this. Thanks for watching, and stay tuned to it.